49 years. That's how long a piece of bone sat in a museum, hiding one of the most controversial secrets in American archaeology. When a farmer in Washington state accidentally uncovered a mastodon skeleton in 1977, nobody could have imagined that this discovery would fundamentally rewrite everything we thought we knew about who first set foot on this continent, and more importantly, when. A single bone fragment, embedded deep within a mastodon's rib, would become the smoking gun that changes human history itself. Let's travel back to a humid August afternoon in 1977. The location is Sequim, Washington, nestled on the Olympic Peninsula. A man named Emmanuel Manis, known to everyone as Manny, was going about what seemed like an ordinary day on his farm. He had a simple project in mind: dig a pond on his property. He fired up his backhoe, ready to break ground and create what would be a useful water feature for his property. But as the excavator bucket bit into the earth, something unexpected happened. The backhoe struck something hard, very hard. Manny climbed down to investigate, and what he found would change everything. Protruding from the soil were massive tusks. Not just any tusks, but the tusks of an American mastodon. Now, finding prehistoric remains isn't entirely unheard of in North America, but finding an intact skeleton, or even substantial portions of one, is extraordinarily rare. Manny recognized the significance of his discovery and did the right thing. He contacted local archaeologists at Washington State University. Leading the charge was a renowned archaeologist named Carl Gustafson, a man who would spend the next decades studying this remarkable specimen and defending a controversial theory that would eventually reshape our understanding of human migration to the Americas. When Gustafson and his team arrived at the Manis farm, they found themselves staring at the skeletal remains of what appeared to be an adult male American mastodon. These creatures were giants of the Ice Age, members of the elephant family that roamed North America until their extinction roughly 13,000 years ago. This particular specimen showed signs of age and wear. The teeth were ground down to nubbins, worn from years of grinding vegetation. The bones suggested an animal that had lived a long life before meeting its end in this valley south of Sequim. But as Gustafson's team carefully excavated the skeleton, they made a discovery that would become the center of an intense scientific controversy. Embedded within one of the mastodon's ribs was a fragment of sharpened bone. Not just any bone fragment, but one that appeared to have been deliberately fashioned into a point. Gustafson examined it carefully and proposed a startling hypothesis. This wasn't a random bone fragment. This was a weapon. Specifically, it was the tip of a projectile point that had been driven into the mastodon with such force that it broke on impact, leaving a portion of the weapon lodged within the animal's skeleton. If Gustafson was correct, this represented something extraordinary. It suggested that humans had hunted and killed megafauna in the Pacific Northwest thousands of years before the well-known Clovis culture emerged with their distinctive stone spear points. The Clovis people, long thought to be the first Americans and the first big game hunters of North America, lived approximately 13,050 to 12,750 years ago. But if this mastodon was indeed killed by humans, and if the bone fragment really was a weapon crafted by human hands, then humans had arrived in North America centuries before Clovis. This theory was met with enormous skepticism from the archaeological community. Scholars questioned whether the bone point was truly fashioned by human hands or was simply the result of natural processes. They questioned the dating methodology. They questioned whether the mastodon had actually been killed by humans or had simply scavenged the bone fragment from another source after the animal's death. They argued that the bone could have become embedded in the rib through natural burial processes, that weathering in time could create apparent shapes that mimicked human manufacture. The controversy raged through the 1980s and 1990s, with Gustafson defending his findings against waves of criticism from established researchers and institutions. He published papers, presented evidence at major conferences, and continued excavating at the site, uncovering additional bone tools and fragments that he believed suggested human activity. He found other bones that appeared to have been shaped by human hands and worked into tool forms, but despite his efforts and his accumulated evidence, the broader archaeological establishment remained stubbornly unconvinced, and many prominent researchers dismissed his interpretations as speculative or misguided. Then, in 2011, something significant happened. A research team led by Michael Waters from Texas A&M University decided to re-examine the Manis mastodon materials using modern dating technology that hadn't been available to Gustafson 40 years earlier. Waters and his colleagues employed new radiocarbon dating techniques with extraordinary precision. They also used cutting-edge digital reconstruction methods to examine the bone fragments embedded in the rib. The results were remarkable. The bone point and the site were definitively dated to approximately 13,800 years ago. The digital reconstruction revealed that the fragment was indeed a thin, smoothly shaped projectile point, featuring sharp lateral edges and a plano-convex cross-section. These characteristics were entirely consistent with human manufacture. But the team didn't stop there. They conducted DNA analysis on the bone point itself and discovered something astonishing. The weapon was made from the bone of another mastodon. This meant that humans didn't just hunt mastodons. They fashioned weapons from the bones of other mastodons to hunt them. This speaks to a sophisticated level of technological knowledge and environmental understanding. It suggests hunters who understood their prey, who knew how to process bone into functional tools, and who had developed hunting strategies sophisticated enough to kill creatures many times their own size. The evidence now seemed overwhelming. The bone point showed distinctive characteristics that separated it from naturally fractured bone. The shape was consistent with other osseous weapons found at pre-Clovis sites. The dating was precise and reliable. The mastodon rib showed clear evidence of having been struck by a penetrating object, with bone displacement consistent with a violent impact from a projectile. Moreover, the healing response around the wound suggested that the mastodon survived the initial attack, presumably to be hunted again and successfully killed, or to die of complications from the wound. Think about what this means for a moment. 13,800 years ago, in the lush valleys of the Pacific Northwest, humans were already established enough to actively hunt megafauna. They had developed weapons technology that could penetrate the hide and bones of massive animals weighing thousands of pounds. They understood animal behavior and vulnerability, knowing where to strike a mastodon to inflict a mortal wound, or at least cause injury significant enough to incapacitate the creature. They coordinated hunts that required strategy and cooperation among multiple hunters, probably involving tracking, positioning, and synchronized action. They had already spread across and adapted to North American environments with remarkable success, demonstrating the capacity to exploit diverse ecosystems from coastal regions to inland valleys. This wasn't a recently arrived population struggling to survive in a new land, experimenting with unfamiliar animals and environments. These were established hunters with sophisticated knowledge of their ecosystem, their prey animals, and effective hunting techniques. Implications rippled through the archaeological world. If humans were in the Pacific Northwest 13,800 years ago hunting megafauna, then the conventional timeline of human arrival in the Americas was fundamentally wrong. The Bering Land Bridge hypothesis, which suggested that humans first entered North America by crossing a now submerged land bridge between Siberia and Alaska during the last ice age, became more complex. Humans must have arrived earlier than previously thought, perhaps by maritime routes that left little archaeological trace, or through multiple waves of migration. The Manus mastodon discovery suggested that pre-Clovis peoples occupied diverse environments across North America and had achieved remarkable technological sophistication. The stone tool record from sites predating Clovis was sparse and variable, leading many archaeologists to believe that pre-Clovis peoples were less skilled hunters than Clovis peoples. But the Manus site revealed something different. The bone projectile points used to hunt mastodons were effective weapons, manufactured with care and precision. They were different from the Clovis points that would emerge later, featuring a different shape and construction method, but they were equally deadly. This raised another fascinating question. If pre-Clovis peoples in the Pacific Northwest were hunting mastodons with bone weapons, what were other pre-Clovis populations doing elsewhere in North America? Archaeological evidence from places like Monteverde in Chile suggested human presence dating back 14,500 years. The Channel Islands off California showed evidence of human occupation going back 13,000 years. These sites, along with the Manus mastodon, painted a picture of a North America that was far more populated and complex than scholars had previously imagined in the pre-Clovis era. The Manus site itself revealed additional secrets. Beyond the mastodon skeleton, excavations uncovered fragments of bison bone, some showing signs of human modification and butchering. These bones were found stratigraphically below the mastodon, preserved in glacial debris. On the surface level where the mastodon was found, more bison remains appeared, also showing evidence of human modification. This suggested that the area was a hunting ground, a place where humans regularly killed large animals and processed their carcasses for food, tools, and other materials. The Manus site was no isolated kill site, but part of a broader pattern of human subsistence and settlement. When you stand back and look at the big picture, the Manus mastodon represents something profound about human capability and resilience. The people who hunted this mastodon lived during the Bulling-Alarud period, a time of warming climate and changing ecosystems at the end of the last ice age. The world around them was in flux. Glaciers were retreating. New environments were opening up. Megafauna populations were fluctuating in response to climate change and human hunting pressure. Within this context, humans demonstrated remarkable adaptability. They developed weapons and hunting strategies specifically designed to exploit megafauna. They thrived in the challenging environment of the Pacific Northwest. The mastodon itself provides a window into the life and death of these ice age giants. American mastodons were smaller than woolly mammoths, but still formidable creatures, weighing 6 to 8 tons on average. They had long tusks, powerful bodies, and were well adapted to the temperate forests and grasslands of North America during the Pleistocene epoch. This particular individual was aged and showed signs of wear. Its teeth were nearly ground to nubs from decades of processing tough vegetation, evidence of a life spent exploiting forest resources. When it died, whether from the wounds inflicted by hunters or from complications resulting from infection, it fell to the ground in this valley and was eventually buried by natural processes and glacial debris. For nearly 14,000 years, this bone fragment remained hidden, silent testimony to an encounter between human and beast that had faded into prehistoric obscurity, waiting for discovery and vindication. The controversy surrounding the Manis mastodon reveals something important about how science works, particularly in archaeology. Scientists are rightfully skeptical of extraordinary claims. When Gustafsson first proposed that humans had killed this mastodon, the evidence was circumstantial, and the dating was uncertain. The bone could have been naturally fractured. The presence of the bone in the rib could have been coincidence. Scholarly skepticism was appropriate and necessary. However, skepticism that persists in the face of accumulating evidence becomes dogmatism. When modern dating techniques and digital analysis provided overwhelming support for Gustafsson's hypothesis, the scientific community gradually accepted the evidence. This illustrates a critical point about historical understanding. Our knowledge of the past is constrained by the evidence that survives and by the technology available to examine that evidence. For 40 years, the Manis mastodon sat in museum collections, known but not fully understood. When the right technology came along, when researchers with the right expertise decided to reinvestigate, the ancient secrets encoded in bone were revealed. This is how science progresses, through patient accumulation of evidence, through the willingness to question established narratives, and through technological innovation that allows us to see the past in new ways. The practical implications of the Manis discovery are significant. It suggests that North American prehistoric cultures were far more sophisticated than previously credited. The notion that pre-Clovis peoples were simple, unsophisticated hunter-gatherers gradually yields to a more nuanced picture of diverse populations, with varying technologies, subsistence strategies, and levels of complexity. Some groups hunted megafauna with bone weapons. Others relied on small game, plant gathering, and maritime resources. The diversity of pre-Clovis cultures reflects diverse environments and diverse human responses to those environments. Furthermore, the Manis discovery impacts how we think about the extinction of North American megafauna. The extinction of mammoths, mastodons, giant ground sloths, saber-toothed cats, and dozens of other species occurred roughly 12,800 years ago, coinciding with climate change at the end of the Ice Age and with the expansion of human populations across North America. The Blitzkrieg theory suggested that Clovis hunters swept south through the Americas, Blitzkrieg style, killing off megafauna in rapid succession. But if humans had already been hunting mastodons successfully for over 1,000 years before Clovis, then megafauna extinction wasn't a sudden event triggered by the arrival of a new, superior hunting culture. Rather, it was the culmination of long-term human hunting pressure, climate change, and ecological disruption accumulating over centuries. As human populations grew and spread across North America, as hunting technology improved and became more efficient, and as climates shifted in ways that destabilized megafauna populations, the pressure on these creatures intensified. By the time Clovis peoples emerged, the extinction process was already well underway, accelerated perhaps by the final technological and strategic innovations these particular hunters brought to bear. The Manis mastodon tells us that humans didn't suddenly arrive in North America and immediately drive megafauna to extinction. Instead, humans and megafauna coexisted for centuries in complex dynamic relationships. Sometimes, humans successfully hunted these massive creatures. Sometimes they scavenged from them. The ecosystem was in constant flux, responding to climate changes, to hunting pressure, and to the behavioral and technological adaptations of human populations. The extinction of megafauna was likely overdetermined, resulting from multiple factors rather than a single cause. In 2019, the story took another interesting turn. Claire Manis Hattler, the widow of Emmanuel Manis, donated the entire collection of mastodon remains and related artifacts to the Washington State Historical Society. This was a generous gift that recognized the importance of the discovery and ensured that the materials would be properly preserved and made. The Washington State Historical Society recognized the Manis mastodon as one of the 3 most important archaeological finds in Washington State history. The other 2 are the East Wenatchee Clovis site and the ancient one, known as Kennewick Man. These 3 discoveries collectively establish the timeline of human habitation in the Pacific Northwest and document the interaction between early humans and the megafauna that shared their world. Together, they provide evidence of a complex human history extending back at least 14,000 years in this region. Looking at the broader story of human prehistory, the Manis mastodon represents a turning point in our understanding. For decades, the conventional narrative placed the earliest peopling of the Americas quite recently, with Clovis peoples arriving perhaps 13,000 years ago or slightly earlier. This model implied that Native American cultures developed from relatively recent migrations, and therefore were less ancient and less established than Old World civilizations. The accumulating evidence from sites like Manus, Monteverde, the Channel Islands, and many others fundamentally challenges this narrative. It suggests that human presence in the Americas is ancient, that cultures developed through long processes of adaptation and change, and that Native American peoples have been inhabiting and shaping these continents for at least 15,000 years, possibly longer. This has profound implications not just for archaeology, but for how we understand human diversity, cultural development, and the accomplishments of indigenous peoples. It means that Native Americans were not recent arrivals, but rather ancient inhabitants with deep roots in their lands. It means that the cultures and societies encountered by European explorers in 1500 and beyond were the products of thousands of years of cultural development, not recent arrivals themselves. It suggests that indigenous peoples of the Americas achieved remarkable cultural sophistication through processes of cultural evolution operating over immense timescales, the same timescales that produced the civilizations of Eurasia and Africa. The Manus Mastodon, in its small way, helps restore indigenous peoples to their rightful place in human history. These were not primitive peoples, but accomplished hunters and toolmakers. The societies they built were not new, but ancient. The knowledge they possessed was the accumulation of centuries of experience and experimentation. The achievements they would later display in agriculture, architecture, astronomy, and social organization were not borrowed from the Old World, but were products of indigenous innovation and development. As we reflect on the significance of the Manus Mastodon, we might also consider what other secrets remain hidden in the archaeological record, waiting for the right combination of evidence and technology to reveal their mysteries. How many other sites exist that contain evidence of early human occupation in the Americas, but have not yet been recognized or properly investigated? How much of the pre-Clovis record remains invisible to us, simply because we do not yet have the technology or methodology to detect it? The Manus Mastodon reminds us that the past is far more complex and mysterious than any single discovery can fully capture. The story of the Manus Mastodon is ultimately a story about knowledge, discovery, and the nature of historical understanding. It is a story about a farmer whose backhoe struck something unexpected, about an archaeologist who recognized the significance of a bone fragment and spent decades defending a controversial interpretation, about technological innovation that eventually vindicated his conclusions, and about the gradual acceptance within the scientific community of a new understanding of human prehistory. It is a story about how the past speaks to us across vast spans of time, encoded in the very bones of the creatures that shared the world with our ancestors. 49 years passed from the initial discovery to the vindication of that discovery through modern scientific analysis. In those decades, the Manus Mastodon went from being a controversial and disputed find to being recognized as one of the most significant archaeological discoveries in North American history. Its importance grows not because new bones have been discovered or new data recovered, but because we have finally developed the capability to read the œil du temps, story that the bone fragment has been trying to tell us all along. That bone point, embedded in the mastodon's rib where it has rested for nearly 14,000 years, is a voice from the past, speaking to us across the millennia with a simple and profound message. Humans were here. They were skilled, they were resourceful, and they were engaged in the great adventure of exploring and settling a new world. The Manus Mastodon changes the human timeline, not because it introduces an entirely new narrative, but because it pushes back the dates and enriches the details of a narrative we are still learning to read. Every new discovery, every new application of analytical technology, every decision to reinvestigate old materials with fresh eyes has the potential to add another chapter to this story. The mastodon's bones hold more secrets still, waiting for future generations of scientists with even more sophisticated tools and techniques to uncover them. The timeline of human history in the Americas is still being written, still being revised and expanded with each new discovery. The Manus Mastodon stands as a powerful reminder that the past is never truly past, that it continues to speak to us, and that we continue to listen with ever-growing appreciation for the complexity and wonder of human history. The scientific community's eventual acceptance of the Manus evidence represents a significant shift in archaeological thinking. Today, most archaeologists accept that humans entered North America much earlier than previously believed, probably by 15,000 years or more. Evidence of human occupation predating Clovis continues to accumulate from sites around the Americas. The notion that Clovis peoples were the first Americans is definitively rejected. The Manus Mastodon played a crucial role in this paradigm shift, providing clear, compelling evidence that pre-Clovis peoples were sophisticated hunters capable of taking down the largest animals of their time. Beyond its importance for understanding human history, the Manus mastodon captures something primal about human existence. It speaks to our ancestors' courage in facing dangerous animals, their ingenuity in developing effective weapons, and their determination to survive in a challenging world. That single bone fragment lodged in a mastodon's rib represents countless hours of human effort. The time spent fashioning the bone point from another mastodon's skeleton, sharpening it to a needle-like tip, attaching it to a shaft to create a functional spear, the dangerous encounter between hunter and massive prey, the successful strike that penetrated hide and bone, and the memory of that encounter preserved by chance in the skeleton of the animal for nearly 14,000 years. The discovery also highlights the importance of museums and research institutions in preserving and studying the past. The bone fragments had been in museum collections, available for study, but not fully understood. When researchers like Michael Waters decided to reinvestigate these materials using new techniques, they unlocked secrets that had been hidden for decades. This demonstrates the value of maintaining comprehensive collections, of preserving materials that might seem unimportant or already fully studied. Future technologies will almost certainly reveal aspects of the Manus mastodon that we cannot yet imagine. DNA analysis of the bone may eventually yield information about the genetics and health of both the mastodon and the humans who hunted it. Isotopic analysis might reveal information about diet, climate, and seasonal patterns. Advanced imaging techniques might reveal microscopic traces of human activity not yet recognized. The Manus mastodon also reminds us that history is not fixed and unchanging. New discoveries continue to reshape our understanding of the past. The conventional wisdom of one generation becomes outdated when new evidence emerges, or when established evidence is re-examined with fresh perspectives and new technology. This is how historical science works. It is provisional, always subject to revision in light of new evidence. The story of the Manus mastodon is partly the story of scientific skepticism, eventually yielding to compelling evidence, of the archaeological community slowly accepting a new understanding of human prehistory. When we consider the broader context of human migration and settlement in the Americas, the Manus mastodon fits into a growing body of evidence, suggesting that human arrival was more complex and occurred earlier than traditional models proposed. The Bering Land Bridge model posited a single migration event, with populations spreading relatively rapidly throughout the Americas. But the archaeological evidence increasingly suggests multiple waves of migration, possibly along coastal routes as well as through interior passages, with human populations arriving at different times and spreading through diverse routes. The Manus site provides evidence of established hunting populations in the Pacific Northwest by 13,800 years ago, which fits into this more complex model of human expansion. The technological innovations demonstrated at the Manus site are particularly significant. The bone projectile points represent a form of osseous technology, the working of bone and ivory into functional tools. This technology appears in various pre-Clovis sites, but reaches a particular sophistication at the Manus site. The ability to manufacture a bone projectile point sharp enough to penetrate a mastodon's rib cage and the bone beneath required considerable skill. It required understanding the properties of bone, how to work it into the desired shape, and how to attach it to a shaft to create an effective hunting weapon. This knowledge accumulated over generations, passed down through cultures and refined through practice and experience. Moreover, the bone point itself tells a story of resource management and ecological knowledge. It was made from another mastodon's bone, suggesting that humans not only hunted mastodons, but also processed their carcasses completely, using virtually every part. In addition to meat, the bones provided material for tools. The ivory tusks could be carved into various implements. The hide could be used for clothing and shelter. Even the larger bones could be used structurally. This comprehensive utilization of resources suggests a sophisticated understanding of how to exploit megafauna efficiently and completely. The context of the Manus site within the broader Pacific Northwest environment is also revealing. The Sequim area where the mastodon was found is today a relatively temperate environment with mild winters and moderate precipitation. 13,800 years ago, it would have been somewhat colder and wetter with different vegetation and different megafauna populations. However, it would still have been a relatively favorable habitat compared to areas closer to the retreating ice sheets. The presence of humans hunting in this region 13,800 years ago suggests that the climate and environment were conducive to human settlement and subsistence hunting. They would have had systems for food processing and storage to utilize the meat from these large animals efficiently. They would have had social institutions for transmitting this knowledge to younger generations. In short, they possessed the elements of culture in the full sense: language, technology, social organization, and learned behavior patterns passed between generations. The Manus mastodon thus represents not the beginning of human presence in the Americas, but rather a window into an already established and sophisticated human culture in the Pacific Northwest. This culture had survived and adapted through the end of the Ice Age, witnessed climate change, and continued to thrive. The people represented by the Manis site were not primitive newcomers learning to survive in a strange land, but rather accomplished hunters and tool makers continuing a way of life that had been refined over generations.